All right, guys, so we're going to go through the study guide. This worksheet over here was given to you in your Canvas class as a study guide. And I'm going to show you how to do one problem from each section. So we'll go down. The first part says mole particle conversions. We're going to go down and do number 5 because it's kind of the hardest problem in there. So the first, let's go ahead and look in our, what would you write down if you were doing the problems, all that. How many molecules are in 0.400 moles of N2O5? All right, so we need to know molecules in moles N2O5. Well, the first thing that we're going to do is we're going to refer back to our moles roadmap. And we have molecules, or we want molecules, and we have moles. So in this case, we're going to use this arrow. I'm going to go from moles to molecules. So this is going to be the conversion that we use. Right, so the number of molecules in a mole over 1 mole. So we set up our factor label, our conversion problem. 0.400 moles. Now notice, we don't have to find the molar mass on this one. So the moles cancel, and we're left with just numbers to multiply. Now, in this problem, we have a regular number and we have a scientific notation number. You could type that into your scientific calculator. That'd be fine. But we're also going to go back and review those rules for how to do scientific notation. I'm going to go ahead and put this number into scientific notation. So it would be 4 times 10, and I'm moving this number 1 place to the right, so it is a negative 1. And I'm going to say times 6.02 times 10 to the 23rd. So my rules are I'm going to multiply the factors. Let me pull up my calculator. So I will multiply 4 times 6.02, 24.08. So we'll have to fix that number here in a second. And then I add my exponent. So negative 1 plus 23 is 22. Now I look at this and I see, all right, well, that is not proper scientific notation. So I need to make the factor between 1 and 10. So I'm going to move this over. And instead of doing any math, I'm going to remember our acronym. So I move my decimal place to the left. So I'm going to add 1 to my exponent. So my actual answer is 2.408 times 10 to the 23rd. Because left add, right subtract. All right, so my actual answer is 2.41 times 10 to the 23rd. Now you might say, why isn't it 2.408? Well, if we look back, we had 3 significant digits and we had 3 significant digits. So our actual answer needs to have 3 significant digits. The 8 tells the 1 to go up. And there's our answer. That's a lot of thinking. It's a lot of thinking. All right, give me a thumbs up if that made sense as we went through it. Okay. All right, hopefully you wrote down the examples so that you're following along. All right, the next section is mole to mass conversions. So which one do we want to do? Let's do one with the compound. Ooh, here's a good one. We'll just go to number 5 probably in all of them. And I know, 5. Find the mass in 2.6 moles of lithium bromide. Okay. So we need the mass. We have 2.6 moles. And then we have these words, lithium bromide. All right, let's find lithium. What is that? What's the formula for that? Lithium's right here. So wait, lithium's a metal. So we know that this is an ionic compound. So with ionic compounds, we just say the name of the ions. So we have lithium, and it's going to have a +1. Okay. So we're just going to write that down. And bromide, because they all get the "ide" ending, would have a -1. So that was actually easier on us than we were ready for. So it's LIBR. That's our appropriate formula. All right. So now we can go to our mole roadmap now that we know what we're dealing with. And we can say, all right, I need mass and I have moles. So I have moles and I want to go to mass. So I'm going to put molar mass on the top and 1 mole on the bottom. All right. So I'm going to start out with 2.6 moles LIBR times 1 mole. I need the molar mass of lithium bromide. So I have to calculate that. If I look at my formula, there's 1 atom of lithium, 1 atom of bromine, which is why we had to find the proper formula. I go back. Bromine is 79.9 average atomic mass. Lithium is 6.9 average atomic mass. Now, this is pretty convenient because 1 times this number is itself. So we can just add those up. When we add them up, I'm going to bring in my calculator. $86.8. And so that's the number that goes up here. We don't have to write this per mole part because that's what this says, 86.8 grams per mole. Okay, so our mole cancels. We're left with grams. That's what we want. Our problem is set up correctly. And then we go multiply straight across. So we already had 86.8 times 2.6, 225.68. So then we've got only 2 significant digits there. So if I were asked to put it in proper significant digits, I'm multiplying and dividing, I would have to say it was 230 grams of lithium bromide. I will count either one of these right on your test, but sometimes it will say significant figures. So you need to be mindful of that, especially when you're reviewing. Okay, give me a thumbs up if that makes sense. I see no thumbs. Okay, we got a couple thumbs. All right, so that's the example there. The next section says mole to volume conversions. We have not actually done very many of these in class. There's like 1 on your test, so they're not a heavy weight, but we're going to go through one. Let's see. Let's go ahead and do one of these ones that said, like, do they all say? Let's go ahead and we'll just stick with it. We'll go with the last one on each section. This STP. We have talked about STP in class, but it's been a minute. So let's talk about that one. So it says, what is the volume of 0.05 moles, so that's good. We start in the middle of the roadmap. Neon gas at STP. Now, this STP is there for information. Like, at standard temperature and pressure is when these gases are 22.4 liters. But it's really just extra information. You don't actually have to use these numbers in the calculations that you're doing. So don't let that throw you off. All right, so we start with what we have, 0.05 moles. And we go back to our roadmap. We know moles is right in the middle, and we're trying to get to volume. Volume's up here at the top. So if I'm going from moles to volume, I'm going to use this conversion, 22.4 liters over 1 mole. So moles canceled. I'm left with liters, which is what I want. And I'm going to go 0.05 times 22.4 equals 1.12. And that's it. So those ones are a little intimidating because you have this extra information here. But it's still go to the roadmap, use the conversion that you pick up along the way, and do your calculations, just like unit conversion that we did way back at the beginning of the year. Okay. So let's go ahead and do. Ooh, our time is getting away from us. Okay, now mixed practice. Mixed practice, you have to figure out where you're going in the roadmap. Okay, sometimes you're going to have 2 steps. So let's do one that's a little bit more complicated with some extra information. Okay, let's just read number 10 and we'll say how to set it up. That way we're consistent with our last one in the set. Okay, the shaft of that same golf club, so that we were talking about some golf club and another problem, probably contains around 35 moles of graphite, a natural form of carbon. Okay, so we are working with carbon. How much might the shaft of the golf club weigh? Okay, so there's a lot of extra words in there, but what are we being asked? When we're asking for a weight or a mass, we're going to go to grams, and we're given moles. So in our work, we're going to say, we don't know mass. We have 35 moles of, now it says graphite. Are you going to find graphite on the periodic table? No. You're going to find carbon on the periodic table. And then it's the same kind of problem. Okay, so we're going to go for moles. Always start with what you have. And then we go back to the roadmap. That roadmap is best friend in this unit. So we had moles, and we're going to go to mass. So if we follow that arrow, moles to mass, we're going to pick up this conversion right here. So 1 mole goes on the bottom. I got to find the mass. And luckily, we're just working with carbon. So carbon 12.0 or 12.0, we don't really have to do any calculation. Moles cancels. We're left with our grams, which is what we want. Multiply straight across. 35 times 12 divided by 1. We don't have to divide by 1 because everything divided by 1 is itself. So 35 times 12 is 420. Oops, that is totally crooked. All right. Well, let's do. I want you to have some time to do some on your own. These multiple variable conversions are the hardest problems that you have on the test. There's only a couple, but you need to be able to know how to do a two-step problem. So let's be consistent. Let's just go ahead and do the last one, and that is multiple steps. So do the second to last one so you have time to work. Okay, how many particles are there in 1.43 grams of a molecular compound with a gram molecular mass of 223 grams? Okay, there's some thinking in that, so let's go ahead and talk and do that one. Let's see if we have enough space right here. So we don't know particles. That's what we're being asked. We are given 1.43 grams. We don't even know what we're working with. So, like in my mind as a student, if I'm looking at that, I'm going, I can't do this problem. I don't know what I'm working with. But we're given some very critical information. The molecular mass is already given to us, and it is 233 grams. So let's go to our roadmap and see if we can, which we actually can do this problem. So we're trying to go particles. We want to get two particles. Okay. And we have grams. There's no arrow. So you have to go up. So it's just like on a map on a real road. You have to follow the roads that are given. So you can go here and then go from moles to particles. So it is 2 steps, but look for your path. So we are given grams. We're going to start with what we're given. And we don't even know what we got, but we can still do this problem. We're going to go from mass to grams. So we're going to get 1 mole on the top, the molar mass on the bottom, which that's what we're given. So that makes this problem doable. And then, okay, so now we're here. We still have part of our journey to go. So we can go ahead and put that conversion right next to it and just do one big math problem. And this is the conversion we're going to use. We're going to go the number of particles over 1 mole. Okay, so the mole is going to cancel. And then we are going to go ahead and do the math for it. So you might look at that and say, I have to do all that? I have to change all these to scientific notation? Well, you have choices. You could just do this step and then just change one number so that you can use the scientific notation rules. You could plug it into your scientific calculator. I am going to go ahead and choose to just do this step. So I'm going to go 1.43 grams times 1 divided by 233. Then I'll change it to scientific notation and be able to do that a little better. So 1.43 divided by 233 equals 0.006137. Okay. And so that actually lends itself really well to scientific notation because we're going to go 1, 2, 3, so 6.137 times 10 to the negative third times 6.02 times 10 to the 23rd. And I know that in scientific notation, we're just going to multiply the factors. So we pull in our calculator. 6.137 times 6.02, 36.94474. And I'm just going to write it all down. That way I don't have any more rounding errors. And then I'll fix it here in a second. I know that I'm going to add the exponent. So negative 3 plus 23 is 20. But this is not proper scientific notation. So I'm going to refer back to our friend Lars. And I'm going to move my decimal to the left. So move it to the left. I'm going to add to my exponent. So I'm actually going to get 3.70 times 10 to the 21st because I moved it left. So I'm going to have to add to my exponent. I had 3.70 because I need 3 significant digits. And then, well, that's not actually right. The 9 would tell the 6 to go up, but the 4 tells the 9 to stay the same. So make sure you check your work, guys. Okay? And honestly, I would count the 3.70, I would count the 3.69, I would count 3.694474 times 10 to the 21st. That's critical that you get the right exponent. All right. Give me a thumbs up if that made sense. That was a lot of thinking. Okay. All right, I'm going to stop recording and see if I can help you guys. If you need help, I want you to try some of these that we didn't do an example for. And if you need help, let me know. I will either send you the work so you can see it or we can talk through it, however that works. But I do want you to try some of these problems. You do not have to submit them because you're going to take the test on Thursday. But if you take the test and you haven't practiced any, that's not good. So be sure that you are ready